Right? Oxygen's most of the time -2. What's the exception? What is that? It's called a peroxide. It says hydrogen peroxide, you know, that oxygen's going to be O2 -2 off the polyatomic ion chart. Okay? Hydrogen, what can it be? Plus or minus 1. If hydrogen is with a non-metal, what will it be? Positive 1. And if hydrogen is with a metal, it's a negative 1. Right? So it's like one of those friends you might have. They act one way with a certain group of friends, and they act another way with another group of friends. Hydrogen is that person. Okay? Then we have a variety of different ones that we have to solve for. So on this one, if K, MnO4, K is a +1, this is a total of a -8. This all has to be 0 when we add everything up. So manganese was what? +7. +7. Okay? Kylie, what'd you get for C?
Oh, we had to do every other? I did them all.
There you go. Now listen. Fe what?
I got +2.
Okay, we'll look at that and see if that works out, but we'll put it down.
O, I got -2, and H, I got
-2 and H, +1. So those are okay. Let's look at iron, because that's the one that's going to give you trouble. So we have our formula. We put, what is it? Na4Fe. And then you have OH in parentheses with a 6. Now, sometimes you can combine OH and look at hydroxide and not look at each one individually. So, at times, you'll combine two elements as a polyatomic ion and make it easier on yourself, other than putting in -2 for oxygen, which would be a -12. And hydrogen, I'd put +6 for that. Why don't I just go hydroxides off my polyatomic ion table? It's a -1, which is a total of a -6. Sodium is a +1, which is a +4. Then her prediction of iron being a +2 is right.
Yep, good job,
Okay? Okay, it's very important that you know how to do oxidation states, so it'll get to the point where you're not going to have to think about it a whole lot when you do it. Yes, ma'am.
I just have a question because, like, when I did, like, one of the ones we weren't supposed to do, one of the oxidation states came out of fraction. How is that even possible?
Because it's called a formal oxidation state, and it involves
Does it, like,
molecules. It involves molecules. So, right, the oxidation states don't have to be whole numbers. Almost 100%, excuse me, almost 100% of the time they will be, but they could be a fraction because it could be sharing in a different way.
Yeah, one of them had 0 as an oxidation state.
Right, you can have 0 if it's by itself. If an element's by itself, listed by itself, it's going to be 0.
It wasn't by itself.
Okay, well, we can look at it and see if you got questions on that. So, on this one, we get to this rule that I talked about yesterday, and it dealt with electronegativity. If you got two nonmetals hooked together in a binary molecular compound, then what happens is the one with the higher electronegativity, which oxygen has a 3.44, I think, electronegativity, and phosphorus is in the 2s, then oxygen takes on the charge what it would be if it's with a metal. So it takes on a -2 charge, which would be a -12 total. And then so 4 times what would get you 12? 3. So phosphorus would be a +3, and oxygen is a -2. Now, most of the time, what have we been putting phosphorus as? What's the oxidation state we normally write for phosphorus? when it's with a metal?
5.
No, -3. You guys see when it's out in front, first one listed, -3.
Phosphorus?
Phosphorus,
On here
P.
there's no negative.
Is it just 3?
On this one there isn't a negative.
Yeah, make it a negative. Put a negative in front of it. Okay?
Can it, yeah, it can.
It can be a +3. It can be a +3 or +5. So we start looking at these nonmetals and all these numbers we haven't looked at, like chlorine. Chlorine can be a plus, it can be a -1, but it can be a 1, 3, 5, or 7. Is that right?
So phosphorus can be a plus or -3, but only a positive value.
It can be a -3 when it's with a metal, or it can be a +3 or +5 when it's with other nonmetals. Okay? When these elements on the periodic table are with other nonmetals, where we have nonmetals combined, then the rule we use, the one with the higher electronegativity, is the -1, the minus charge.
Are there any others like that? Because, like, there are some over here that don't have any negative. Do we need to change any?
I don't know. We'll get to some of these because this is a pretty good drawing of what we need to do. XeOF. Jacob, what'd you get for that?
Xe6, O -2, and then F -1.
So fluorine has to be a -1. And then oxygen, unless it's a peroxide, or if it's with fluorine, oxygen when it's with fluorine becomes positive. Because fluorine has a negative, or it has the highest electronegativity. But that only happens one time when you have OF2. You have OF2, then the oxygen would be a +2. Okay? Just because of the pairing of the two. I would say that when we look at this, fluorine is a -4 total. And then this would be a -2. To make up for that, it has to be a +6. Xenon, is that a possibility that they have listed?
Yeah.
Okay. Now, don't count on every time that you see an oxidation number, it has to be the one listed above it, or a possible one listed above it. That'll get you in trouble because there might be some that are a rare example where it might not match up with one of those numbers. Okay? All right, very good up to this point in time. You're getting these, and then CO. So oxygen has to be a -2, and so carbon would be a +2.
Yep.
Okay. All right. So 80. We did UO2 +2. So we have a UO2 +2. So it has to come out to be a +2, no longer neutral. So oxygen, unless it's a peroxide, and this one's not, it's going to be a -4, so what's uranium? +6. Everybody agree with that?
Yeah.
Has to come out to be a has to come out to be a +2. So these get easier as you see more examples. NaBi O3. So the I is the problem. +1 -6. The I is a
5.
+5. HASO2. I'm doing the right ones, right? Okay. So the one in the middle is a lot of times the one that is on the one that we have to solve for, because the ones on the ends usually we know. So that's a -4 and a +1, so arsenic is a
3.
+3.
How come the O2 isn't that peroxide? So wouldn't that be -1?
Yeah, you know, that's going to be very rare that it's a peroxide, and if it's a peroxide, it's probably going to be listed just with another element in front. So peroxides are usually binary. I can't think of a situation where a peroxide, when you have it, it's not going to be binary. So oxygen, if it's in a setting where they got 3 or more elements, it's gonna be a -2. It's gonna be -2 when you got 3 elements or more hooked together.
So not even with the uranium, it's not either.
This one,
Yeah.
right, because it has a high electronegativity. It has a high electronegativity. So, all right. Yeah, peroxides, you know, are just not going to come up. If I have it on a test, I'll list it hydrogen peroxide or sodium peroxide. So you, oh, I know that. So I won't do it to where probably I got a formula for it, but just to let you know, heads up on that. And then the last one, you had 2 more to do, right?
Yeah.
NA's a plus. I better do that one.
Yeah.
Holy cow!
This one I couldn't get to work out.
Na2, right?
You need a positive sulfur and there isn't.
So Na2S2O3. So +2, -6 has to come out to 0. So what it's going to be? Each one's going to be a +2, right?
Yeah, but there isn't one.
Right. And like I said, sometimes when you look at this, you'll say, well, it's not listed, so it can't be the answer. It is on this one.
So we can just make things up?
Nope, you can't make things up, but you could use what you know for sure. Oxygen's always a -2.
Yep.
Sodium's a +1. Yeah. You can't make things up. You got to prove it.
So should I add that to
So
the
if you
chart?
prove it, you can if you want to. I don't care.
What's part
But
of it?
if you do that on everyone, then you might have a bunch of numbers. So.
Yeah. So can I put like +2 on that?
Yep. Sure. Okay. Now, when you do an AP test, and that, I don't know, probably just have a handful of you do the AP test, but if you do it, you don't have that periodic table you can use. All you have is the periodic table with the symbols and their weights and their
You have to
atomic
know
number.
Their oxidation.
You have to know their names. Ca, they just give you Ca, so you have to know it's calcium.
Does it give the oxidation states?
No.
Ah.
No. You have to know. You have to know by position. Group 1's a +1. Group 2's a
Those are
+2.
easy. It's when you get into.
Well, that's the ones. They're not going to give you ones that have variable oxidation states.
Oh, okay.
Yeah. It'll be like group 17's -1. Polyatomic ions, you have to memorize those. Nitrates -1. Sulfates
Oh, I
-2.
know like their oxidation states, but I don't always know their names.
Okay, and then the last one you had to do is calcium's a. So this is the way I would approach this one. I like to pull out the polyatomic ion and deal with polyatomic ion without putting all the numbers in. Can you do that? Yeah, you can do that. Nitrate you can pull it out, treat it just like on its own. Know that this is a -6, so then nitrogen has to be +5. If I try to do it in here, then I got 6 oxygens, which would be a -12. I have 2 nitrogens. I got to figure out what that one. I got a +2 here, and then I have to go through and figure it out. A lot easier to deal with polyatomic ions on their own. Pull them out. If you know it's a polyatomic ion, to do that, it's much easier to do that. Okay. Now I need to get into a topic here today, since you've done some of those. Did you, Alan, did you want to go through, did you see one that was kind of an odd one?
There were 2 like weird ones, like AS4 was one. Like I didn't understand when we do that.
Okay, and it was by itself? So it's like O2 by itself, or CO2 by itself. It can't lose electrons to itself.
Yeah.
That means it gains electrons, which means they cancel out.
So it'd be 0.
Be 0.
And then there was C6H12O6.
Okay, let's go look at that one.
With the AS4,
I had C would be a +4, H would be a -1, and oxygen would be a -2.
Okay, but hydrogen's with other nonmetals,
Yeah.
so it's +1.
So it has to be positive.
Yeah, so this is a +12. This is a -12. So that's a +12, and this is a
That's why I don't see how it can be
12.
0.
And that looks like it's 0.
Because if you have positive 4, negative 1, and negative 2, it comes out to 0. Because you'd have 24 with the hydrogen and oxygen, and then you'd have a positive 24 with the carbon.
Well, the way that comes out, it should be 0. I'll have to look at it and see. Okay, I'll have to look at, because some of those carbon, hydrogen, oxygen combinations, carbon can be a variety of different, because they're bonded molecularly, they can be a variety. So we'll look at that later on. We'll come up with some examples, how that works. What we need to do is we need to transition this information to an equation where we have electrons being lost and gained. It's called redox reactions. So what we're going to do is look at oxidation reduction reactions. We'll just do a couple today.
Are we turning this in?
No.
You just want to see how you do. $50 is not that much to think about.
Okay, go ahead and write that down. This is also called shorthand redox reactions.
What?
Redox reactions.
2 hours you'll be here. And plus, it doesn't even count towards your good things. Fail it.
I know, I failed it.
Okay, so the first thing you have to do on a redox reaction is you have to go through and assign oxidation states to every element in the reaction, and to see if there's any changes in their charges. Most reactions are redox reactions. Most reactions that take place are redox reactions. Precipitate reactions are not redox reactions. Neutralization reactions are not redox reactions. Okay, so those last two groups, they are not redox reactions because we don't have any exchanges of electrons. All we do is have exchanges in the same ion. You know, the ions are exchanging places. And here we have exchanging, electrons start to move around, move from one thing to another. They move from an atom that really does not have a strong hold on the electron to something that really, really wants it. And so you get that combination, then you get a redox reaction when that takes place. Okay. So I'm going to pick out one here, and we're going to take a look at it and see if it makes sense how it's going to rearrange. You go across, fill in all your oxidation states. Take a minute to do that. The ones that will give you trouble is the Cl and the S. The other ones should be quick, easy, look them up. They're on your periodic table, boom, boom, boom. Maybe sulfur would fit in that category. It might be a little bit tougher, but probably not too bad.
Do you have to balance it?
I believe, no, you don't have to balance it. For purposes of doing this, we're not going to, this is one that's unbalanced that we could go balance, but for right now, we're just going to leave it like it is and not balance. You can use loss of electrons and gain of electrons to balance reactions. And we don't do a lot of that. I used to like to do that because it was, for me, I'm kind of goofy. For me, it was fun to do that. Reactions that you can't balance by sight, you can balance by balancing out the electrons that are lost and gained. And then once you do that, it makes it easy. So, but we'll do a couple of those.
Wait, so you said no balancing?
No balancing, unless you want to. You can balance it.
Is the... Oh, wait, yeah. This would be hard to balance. I have just 4 and 4.
So I'm not putting the total above them. Some of you might want to put the total above them. But what I do is I put exactly what they are if I've got one of them. So for oxygen, I'm not going to put a -8. I'm going to put a -2. Each oxygen of those 4 will be a -2. So what'd you get for chlorine?
That's a positive one.
Okay. What'd you get for sulfur?
Negative +6.
+6. Okay, here we go. Some of you had seen some different numbers. So SO4 I pull out. I look on my polyatomic ion chart. It's a -2. So oxygen's always a -2 unless it's peroxide, so that means it's a -8. So each sulfur has to be +6.
Oh, so... Okay. Because I just put the charges of the polyatomic ions, so you don't want us to do that.
No, you have to have each individual element.
Okay.
Because you got to find out which element loses and gains. All right, I'm running out of time. So, this word called oxidation. Takes place when atoms lose electrons. We're doing this in regular chem. They're doing really pretty good with it. So oxidation is where we have atoms or ions that lose electrons. Okay, reduction. People, you have to think opposite. Some people mix these up, but reduction is when atoms gain electrons. Or ions, you can put. So, which of these elements gain an electron up here? Look on the left, find their charge, look on the right. Is there any of these atoms that gain electrons? Chlorine, right? +1 to -1.
Oh, okay, yeah.
+1 charge. To get to a -1, how many electrons does it have to gain? 2. So chlorine is oxidized. Electrons negatively charged. So when they say gain, people think the opposite.
Yeah.
Gaining negatives. It's gaining negatives. Okay? So then, what is... so that one, oh, I'm sorry, that one is... So chlorine is being reduced. So chlorine would go down. Okay, so what's oxidized? Sulfur is going from a -2 to a +6. It has lost how many electrons? 8.
That's a lot.
Where did they go? Here. They gain 2 each time. So a total of 4 chlorines would have to be present to pick up those 8 electrons.
So sulfur is being oxidized?
So sulfur is being oxidized. Okay? You got it. There's this term I want to give you, and it's called oil rig.
I remember that.
Oxidation is losing electrons. Reduction is gaining electrons.
I remember it.
But don't think reduction is gaining, because then you'll think it's, gaining a bigger charge.
Oil rig.
Gaining electrons. So oil rig is oxidation is losing, reduction is gaining. Hey, we'll work a lot of these tomorrow. Anybody's going to be gone for testing purposes. I got a lot of classes that are testing, but those are mostly sophomores.
I'll be gone Friday.
Same.
You're going to miss mold day, so you guys are going to miss nothing.